Good morning, students. So I am here once again. Welcome to online classes. Today we are going to discuss an important topic on determinants, that is how to find the minors and cofactors of a certain element in a determinant. I repeat, our topic is minors and cofactors, but minors and cofactors are directly related to a certain element in a determinant, right? So let us see this. What is a minor and what is a cofactor, right? I will directly talk about minors now. Suppose I have a matrix A, it is having A11, A12, A13 and I repeat, it is wrong, A21 and A22, right? Now I have to find M11, that is called minor of element A11, minor of element A11, that is the value which is obtained by removing the row and column containing A11. Can you see this A11 is containing row 1 and also column 1. So I have to remove this row and column and write the determinant of remaining element, that is A22, and determinant of A22 is nothing but simply A22. So that is minor of any element is determined by removing the row and column containing that element and finding the determinant of the remaining element. I think it is clear to you. So let me save this page. Now look at this. Suppose I have a case 1, 2, 3, 1, 1, 1 and 1, 4, 5. I asked you that find minor of element 3. Minor of element 3, right? That is the determinant which is obtained by removing the row and column containing 3. You can see this one is 3. So you remove the row and column containing 3 and find the determinant of the remaining elements. If I remove 3, then what I am left with is 1, 1 and 1, 4. And the value is, it is 1 into 4 minus 1 into 1, which is equal to 3. So this is the minor of element 3. Similarly, in the same case, if I asked you that you find the minor of element 5, right? Then I have to remove the row and column containing 5. Okay. So let me rewrite it. Our this one is 1. Suppose this one is 1, 2, 3, again 1, 1, 1 and 1, 4 and 5. I have to find, I have asked you that find minor of, I repeat, minor of element 5. That will be remove the row and column containing 5. This one is the row containing 5, this one is the column containing 5. So I am left with 1, 2 and 1, 1. This will be 1 into 1 minus 1 into 2, which is equal to minus 1. So minor is simply obtained by removing the row and column containing that element, right? And the last example, let me take. Suppose I will give you a matrix or determinant A. It will contain like this: 1, 1, 0, 1, 1, 1, 2, 3 and 2, 0, 0, 1, right? And it is 4, 0, 0 and this one will be suppose 3. And I have asked you, make it 5 letters. I have asked you find minor of element 5. I repeat, find minor of element 5. This is the determinant value which is obtained by removing the row and column containing 5. So you see, I have removed, suppose this one is the row containing 5, this one is the column containing 5. So what is left? 1 1 0, 1 1 2, and this is 2 0 0. Now if I expand it along row 3, then only 2 will remain, and if I remove this one, this will be 1 0 1 2. This will be 2 multiplied by 2, which is equal to 4. So this is the minor of the element 5. So minor is directly related to just remove that row and column containing that element and take the determinant value of other elements. Here I will tell you, after minor, I think this concept is clear to you. Just remove the row and column containing that element and just proceed to find the minor or determinant value of the remaining elements. Clear? Now there is a little bit of difference between minor and cofactor. So I will make two columns. Conceptually they are the same, but there varies a sign. So here between these two we have only one difference, that is the difference of sign, right? So look at the definition here. Suppose you will write element Mij. I stand for row number, this is for row, and J stand for column, right? Then cofactor of that element is Cij. It is defined as minus 1 to the power I plus j into Mij, where I is the row number and j is the column number. This is the row number and this is the column number. So this is the technical definition. Actually I think you have understood a little bit only. Let me take an example, it will be more clear to you, right? So see, suppose I have a matrix 1 2 4 and 7. Clear? Then let me find first minor of 4 and here cofactor of 4, right? You can see this is 4 is the second row and first column element, so I will denote it as AM21. 2 stands for second row and 1 stands for first column. So AM21, it is given by, just remove minor of 4, so just remove the row and column containing 4. So what is left here? Now if I remove the row and column containing 4, look at this, what is left here with me is 2. So what I will do, AM21, that is the second row and first column, that is denoted by, if I remove 4, then what is left? This is 2, right? But if I find C21, that is cofactor of second row and first column, this will be nothing but minus 1 whole to the power I plus j. I is 2 here because the row number is 2 and j number is 1. So my formula was I plus j into Mij, right? Here I is 2, this is called I and this is called j, right? So let me put the values. Minus 1 to the power I is 2 and j is 1 and this is M21. So minus 1 to the power 2 plus 1 is 3. So it is minus 1 multiplied by 2. Ultimately it will give you 2 only. Minus 1 multiplied by 2, that will be minus 2. See the difference, M21 and C21. M21 is 2 but C21 is minus of 2. So hence there is only difference of minor and cofactor. The difference is the sign difference. Sometimes minor is equal to the cofactor, sometimes minor is the negative of the cofactor, or cofactor is equal to the minor, or cofactor is the negative of the minor, right? So let me take some more examples. You will understand the difference between minor and cofactor. Let me take a 3 cross 3 matrix, that is 1 0 0 0 1 7 and 7 0 0, right? Now I want to, suppose this is 5 0 and 0. Now I have asked you to find the minor of this element. Okay, so minor of 1, there are two ones, so you have to take the one I have encircled, and let us find cofactor of 1. Now this is denoted by m. 1 is the second row element and second column element, so m22. It is the determinant value which is obtained by removing the element. So the element 1, if I remove, this one will be removed and also this one will get removed. The things which are remaining, it will be 1 0 and 5 0. So if I multiply this one, it will become 0. 1 into 0 minus 5 into 0, it will become 0. Now cofactor, if I want to write C22, this will be nothing but minus 1 to the power, this is the row number and this is the column number. So for that, what I will write, 2 plus 2 into m22, right? So minus 1 to the power 4, which is equal to 1, into m22 is nothing but 0. Again it is 0. So here you can see minor is equal to the cofactor. As I have told, minor sometimes can be equal to the cofactor, or minors can be the negative of the cofactor, right? So with this discussion, let me take another the final example one. The example goes like this. Suppose I have 1 2 3 4 6 7 and 1 5 4. Then I asked you to find minor of the element 4. Sorry, there are two 4, so let me take minor of the element 3. That will be called as m. This is the first row and the third column, 1 3. Then you remove 3. What is left here? 4 6 1 and 5. This is 4 into 5, it is 20, minus 1 into 6, which is 6. So 20 minus 6, which is equal to 14. Then if I ask cofactor of 3, this is nothing but minus 1 to the power 1 plus 3 into m13, right? So minus 1 to the power 1 plus 3 is 4. So this is 1 into 14, which is also equal to 14. So here you can see in this case minor is equal to the cofactor, but it is not always. Sometimes minor can be the negative of the cofactor also. It all depends upon this term. If the row and column addition becomes even, then it will be same. If the row and column addition will be odd, then it will be different. All it depends upon I plus j. So let me chalk it out. I plus j, if even, then minor equals to cofactor, and if it is odd, if I plus j is odd, then minor will be equal to minus of cofactor. Is that clear? So this is the thing which you have to we had to discuss today, minor and cofactor, right? Now let me solve one question from your exercise or worksheet. The question is here, find the minor and cofactors of the element of the determinant. The question is, this is our exercise 4.4. Question is, find minors and cofactors of all elements of, this is question number 1, question number 2. Bit second, of all elements of the following matrix or determinant 1 0 4 3 5 minus 1 0 1 2, right? So this is the question. Now let us proceed for the solution of this. Okay, so our matrix is, or determinant is 1 0 4 3 5 minus 1 0 1 2. So I am writing a trick for minors. You just find out the minors first. So first minor will be called m11, It is the row and column containing remove the row and column containing the first element. This is the first row and first column element, so you remove this one. Okay, then what will be left to you? This will be 5 minus 1, 1 and 2. So this is 10 plus 1, which is 11. Then M12 you find. Also you remove the element 0, this one and this one, right? So if I remove this one, this will be 3, this will be minus 1, this will be 0 and this will be 2, right? Okay, let me try it once again. There was some technical problem. So 1 0 4 3 5 minus 1 and 0 1 2. This is our original one. So first I found M11, that is 5 minus 1 1 and 2. This is 11. M12, this will be 3 minus 1, this will be 0 2, right? That is 6. Then M13, you remove the row and column containing 4. This is 3 5 and this is 0 1 and the value is 3. Similarly M21, that is the second row and first column element, you remove this one, right? What is left now? If I remove, this will be 0 4 and here it will be second row is removed 1 and 2, right? So it is 0 minus 4, which is minus 4. Similarly M22 you find by removing this. Is that clear? 1 4 and 0 2. So it will be 2 minus 0, which is equal to 2, right? So similarly there will be 9 minors first. So let me find all of them. Clear? M22 we have already found. Now M23, it will be remove this one, second row and third column. So I'll be left with 1 0 and this will be 0 1 and answer is 1. Then M31, you remove this one and it will be 0 4 and 5 minus 1, right? 5 minus 1. Is that clear? So it will be 0 minus 20, which is minus 20. M32, which is equal to remove the row and column containing 1. Then it will be, if I remove this one, what will be left? This is 1 4 and this is 3 minus 1. So it is minus 1 minus 12, which is equal to minus 13. Then M33, which is equal to, you remove this row and column, this is 1 0 and this is 3 and 5. So it will be 5 only. Now when you find the cofactors, what you have to do is simply follow a sign convention for 3 cross 3. This will be plus minus plus, then again it will be minus plus minus, and this will be plus minus and plus, right? So if I want to write C11, it will be minus M11, right? So let me do that. Clear? First, before starting, let me show you what was our other elements. Clear? So here, yes, M11 is 11, M12 is 6 and 3, this is minus 4 and 2. So 11 6 3 minus 4 and 2. Clear? Then 1 minus 20 and minus 13 and 5. So let me take one by one. 11 6 3 minus 4 2 and 1. I repeat, 11 6 3 minus 4 and 2 and 1, right? So let me tell it. So your minor elements, it will be 11 6 3. Okay, let me take it once again. Then the elements are minus 4 2 and 1, right? Minus 4 2 and 1. And the third elements are minus 20, minus 13 and 5. Minus 20, minus 13 and 5. Is that clear? Now for cofactors, minor is a matrix actually, not a determinant. So just follow the sign convention. What was the sign convention I suggested? This is plus, minus, plus. So only you change the sign of these elements. Other elements will remain as it is. Clear? So what it will be? 11. Change the sign of the encircled elements. This is 3, this is 4, 2 and minus 1. This is minus 20. You change the sign, this one. So this is the shortcut technique. Just change the sign of these elements which I have encircled. So this will be the minor set and this will be the cofactor set. So I think you have got clear idea regarding minors and cofactors. So I am giving you some homework. You solve the questions, and if any doubt is there, in the next class I will be talking about it. This is exercise 4.4 NCERT, all questions. Okay, so that's all for today, and tomorrow I will be dealing with your doubts and topic regarding adjoint and inverse of the matrix, which is very important. But before that, we should understand minors and cofactors first very perfectly, then only we can proceed. Okay, that's all for today. Thank you students.